All right. Hello, everybody, and welcome. Today, this is a very special episode because it's not just, you listen to me and Shashank rattle on back and forth about nonsense. Today, we have a guest. So we have actually, I would even call him like a friend as well, right?
At this point, I think, yeah.
Yeah, I think so. Yeah.
We've known Matt for a while.
Yeah, for quite a while. So Matt is a regular attendee at the South Bay Gen AI Meetup, and is always one of the most interesting people I would say that I get to talk to on like whenever I can. It's always a pleasure when I'm able to talk to them. Like Matt is just like a wealth of knowledge about a bunch of stuff. Whenever I talk about something, he tends to know a lot about it. He's the type of guy who knows a lot about a lot. So I think that you guys are going to enjoy the conversation that we're going to have today. So Matt, he currently works at Cerebras, which is a company which is, in a certain sense, competing with Nvidia at like the highest levels. So they make the largest computing, I don't know, what would you call that? Like the largest
platform.
Yeah, it's like the largest, yeah, it's like probably one of the most powerful hardware compute platforms in the world. And I'm just like super honored that you were able to take the time and chat with us today. So anyways, Matt, why is Cerebras better than Nvidia?
Mark, thanks for those kind words. Yeah, I could ramble on about a long time, but the gist of it is that NVIDIA is a GPU, and it was designed to move textures from memory, from a centralized memory, through the graphics processor and process triangles and pixels and whatnot. And because of that, it doesn't have much knowledge of the content of the data, and so it does however, have a lot of processors in it. And back in the day, if you wanted, tens of thousands of processors for $400, you could buy a video card. And once Nvidia opened up CUDA, and Google got a hold of it and made TensorFlow, and the ML guys realized that they could get access to all the microcode and all those cores, they were off at the races. And the only game in town, actually, AMD was really late in releasing any kind of API for their GPUs. And so NVIDIA was the only game in town. But it was primarily designed to move textures. And because of that, when you want to do a workload, ML is often moving a n by m rectangle of data from memory into the processors and oftentimes back to memory. And what NVIDIA doesn't know how to do is, if in ML workloads, after the very first layer, because of the nonlinear activation function, you often have a lot of zeros. And so there's this thing called sparsity, where a good portion of your data, from 20, 30, 40, even up to 50, 60, 70% is going to be zeros. And so NVIDIA doesn't really know how to not move zeros from memory into the processor. So they've got to move that n by m rectangle, of which a good portion may be zeros. So that takes both time and energy to do. And when you do that, and you spread it on a bunch of all your processors, you've also got to do multiplies and adds, and they don't know how to not multiply and add zeros. And everybody from grade school math knows that, adding and multiplying zeros is a no-op. And so they use bandwidth and processing power to move those non-zeros. Now, to move those zeros. Now that's one thing, right? And that's one advantage. The other one is we pioneered this technology called wafer-scale, and it's been tried in the past unsuccessfully. And what wafer-scale is rather than cut the reticles off the wafer to make individual chips and put them in packages, we leave them all on the wafer and cut the rounded parts off to make a giant square of a chip. So it becomes the biggest chip in the world. It's roughly 12 inches on a diagonal by a long shot. It's got, many, many dozens of rectangles in it, or reticles in it. It's got trillions of transistors. It's got close to 1 million processing cores in it, just in the same chip. And by doing that, when you move data from one chip to the next, it's just a tiny little trace that is extraordinarily fast, way faster than paying the time savings of charging up capacitance to get off of a single die through a package and then a board, and getting through the inductive and capacitance of the chip on the that it's talking to, which is slower and takes more power. And so we got a couple of things going for us. There's the scale of the chip itself that saves power and time. There's the ground up design for ML workloads. We don't have any shared memory, so memory is local, so there's no moving zeros in and out of memory. The ground up design is data flow, so whenever there's a calculation that results in a zero, it just gets dropped, and the next non-zero data gets moved in its place. One of the problems with this, though, is that all the benchmarks are designed for dense data workloads. And so we don't do benchmarks because they're all, sparsity is where we get significant gains in our performance. And so we tend to talk more about how fast our customers can get an answer from the product. And so those are just two examples of why we think we have a better solution than our competitor.
Okay. So I think there's a lot of things that you said there. So I'll just try to dumb it down for at least myself.
Sure.
And for the listener. So I guess what you're trying to say is, Cerebras is better because it's specialized for the particular workload of training LLMs. Would you say that's fair?
I'd say training we're not specific to LLMs.
Okay.
We're a general purpose ML training. LLMs just happen to be the rage right now, but before that it was computer vision and image recognition and things like that. That's where the first real progress got made, and then people realized, and I think our management realized that, hey, well, that's not what's really going to happen. Is LLMs are going to be there. And so a couple of years ago we started investing really heavily in making sure we could run LLM workloads, and that proved to be a pretty prescient thought.
Okay. I guess do you have a sense for what kinds of models have more sparse weights as opposed to dense?
It sort of doesn't matter, actually. The ML, the activation function, there's an activation function called relu, and what it means is any value that result that is less than 0 becomes 0, and any value that's greater than 0 just stays itself. So it's kind of and the nonlinear part is right at 0. You've got this sort of steep angle there, which makes it a nonlinear function. And so that means that after the first layer of processing, you could wind up with a significant number of 0 data.
I guess you mentioned two things that Cerebras does much better than Nvidia. One is the wafer-scale computing. You guys just have bigger, more massive chips, and the other one is dealing with sparsity. So, isn't that a software or design problem that Nvidia could also handle? They could just ignore sparse values somehow with some fancy math or computer science?
They can, and I don't want to speak for their marketing or anything, but my understanding is they can do it on a stride basis, and if they can kind of align the data, the zeros to that stride, they can skip it, but they can't do it completely asynchronous to the way the data comes in at the moment. So you would need to drop the zeros. You would need to have special instructions and things to know that it can drop the zeros, because oftentimes the matrix operation is here's n by m, and here's a thing you're multiplying it by, and it just does all the values and fills them in, and that's what they're really good at. But it's not a data flow architecture. It's more of a MIMD kind of architecture where you're processing multiple data and multiple instructions, but they all have to process at the same time in order to get the data through, and then it has to go back to memory. And so you need special hardware to kind of figure out where the zeros and non-zeros are. But if you have data flow, it just flows through.
So you mentioned data flow versus MD architecture. Can you maybe define what that is?
So in a data flow architecture, the data just goes from one stage to the next and isn't necessarily that aware of anything else, any adjacent data or things like memory size or whatever. It just moves as it moves through the pipeline. Whereas if you have a matrix and you're trying to do an operation like a true parallel processor would, it knows that it's got n by m pieces of data move. It moves it and then does its operation, and then does the next operation, and does the next operation. And that's more of a, I don't know what you'd call it, a matrix flow, where the chunk of data is much bigger.
Okay. So in a certain sense, to like, kind of summarize, is like Cerebras is better because, or like specifically for ML workloads, because the chips are optimized for it. Right. And like Nvidia is more of like a general purpose chip that, since they're like doing like mass market appeal, that like those chips need to work for like gaming and like Ethereum mining and whatever. Yes. Therefore, like they wouldn't be able to make the optimizations that like Cerebras would be able to do. And because of that, Cerebras is potentially like a far better chip for training ML workloads.
Yeah, exactly. And I, early on in the company, our CEO, he's a good marketing guy, Andrew Feldman. He basically said, CPUs are like the hyenas of savannah, right? They'll eat, they'll scavenge for food, they'll kill their own food. They'll basically can just do anything. And they can move around. They're a little mobile. And then you get to GPUs, which are a little less like hyenas, but they do general purpose workload. And what we make is a cheetah. It just does the one thing really, really fast. And everybody, has that immediate visualization of that cheetah running through the savannah from whatever nature show you saw it. And it was a beautiful kind of marketing thing, because not only does it illustrate the point that we're not a general purpose thing, but when you visualize a cheetah versus a hyena, you have this positive and negative. I thought, well, that's really clever. Let's just cast our competitors in this slightest big hyenas, and we're this beautiful, majestic savannah animals. It was really hilarious.
So you mentioned you guys are cheetahs at training.
Training, yes.
And I guess that made me realize that Cerebras doesn't really focus on inference as much. And I was curious, can your chips even do inference well?
Oh, absolutely. So there's this thing coming up, and we knew that we needed to be in the inference game at some point. But if you consider that a lot of the end result of training models, you want to work on cell phones, you want to work on personal computers, you don't work on much, much smaller things. So it makes sense to train a model on a big, hefty compute, resource heavy thing, and then use sparsity to make that model really small, and then run it on some things with maybe a few percentage points loss in accuracy. But there's this whole market coming out now, which, like, if you think about LLMs and some of the image generation networks right now, they're not what I would call real time. They're, you give it some data and it comes out with an answer, and you give it some data and it comes in. It can take milliseconds. It can take, you can make a video that, may take, a minute or two, or music, but it's not really real time in the sense that nothing is depending on that coming out. But now we have this thing, which, I don't know, I call it like edge inference, where you're doing inference that the data is required to come out really fast and get used. And once you fill the pipeline, your inference then becomes this sort of real time model, which is a little different than what a lot of models have done in the past. So we actually partnered with I forget the name of the company recently.
Well, I saw you partnered with Qualcomm.
Right, to help us with the inference part of it.
Yeah.
And the funny thing is, some of these edge inference tasks are so compute intensive that we think we're actually faster at inference for those bigger jobs. And so there's you might train a model on NVIDIA chips and then do inference on our box because its throughput is faster, right? Because it's just a big chip and everything's moving through very fast. And inference, I've heard, takes roughly a quarter of the compute required than the training part, which has this whole backward path and weights and activations and things.
So would Cerebras chips be better for inference for some of the larger models?
Sure, absolutely. Cool. But remember, our box takes 20 kilowatts, and it's it sits in a it's 16U high and sits in a 19-inch rack, and you're not going to put it in a car, and you're not going to carry it around with your cell phone or anything like that. So it's a very big, compute heavy, requires water cooling, for instance. So you can do inference on it, but you have to have a workload that you're going to want to commit that kind of resource to.
It'll be some of the big dogs running some of the larger models, or maybe some of some startup that's taking maybe Llama 3's bigger parameter model, fine tuning it, and maybe serving that.
Quite possibly, yeah. I mean, there's the use cases. It's it's a generic box, right? You have a model, you've got weights, you got activations, you know how big it is, you know how many layers you are. You describe it with TensorFlow or PyTorch or something, and once you've described it and you have your weights and activations, they're just a matrix of data. You just load it onto whatever system you want to load it onto, and you're off the races.
But maybe going back to your original point, you don't market the Cerebras chip for inference. You market it for training. It's the cheetah of training. It's not the cheetah of inference. So assuming no one wants to use it for inference, how big do you think the market is for just people wanting to continuously train models indefinitely? Because let's say you train Llama 3, for example, and then you're done, and then you release it to people. What are these chips doing in between successive model releases? Is there any point to having them, or is it just a dead weight?
Well, at the moment, I can't talk about our marketing and how they're inference, so we'll leave that one aside. But as far as the training part, you train a Llama model, and you're going to train it on data from, say, today, 2024, right? And then 2 years from now, there's going to be another large increment of data out there in the universe that you're going to want to retrain the model on, so it's not dated. So I have a feeling they're going to be retraining models over and over again all the time. So that's one point. The other point is there is a ton of untapped training markets. Like our partner G42, that's about the lion's share of our systems right now. They just released a 30 billion parameter Arabic model, right? Which nobody else has. And so I think as far as workloads are concerned, for the next decade, I can imagine there being a demand for training over and over again, bigger and bigger models to get them more accurate. And it's the training, say, of an LLM is exponential with the number of parameters you have, right? So if you want to train a 3 billion parameter model, like I think GPT-4 is on that order of magnitude.
Trillion,
3 trillion parameter model. You might use X amount of hardware. Well, if you want to go to a 6 trillion parameter model, it won't be 2x amount of hardware. It might be 9x amount of hardware to do it, because it's just that much more data, that much more parameters. The network it has 2 dimensions rather than 1, so you might need significantly more compute to do it. So there's this sort of arms race going on, and who can build the biggest compute for training models.
Yeah, that's true. I think that Sam Altman is not trying to raise whatever it is, $9 trillion or whatever that crazy number is, just because he doesn't want to do more training, right? I think that right now, all these big companies are trying to do as much training as possible. Actually, I remember in an interview with Mark Zuckerberg, he said that the biggest bottleneck right now for training these models is not actually hardware, but just straight up energy. So if we're running into energy constraints, I think that we'll want to get as many optimizations that we can out of the hardware as possible. And with NVIDIA GPUs or any GPUs in general, if there is issues with sparsity, if there's issues with the chips being small, I could see a lot of these companies wanting to use Cerebras hardware just because it's optimized for training ML workloads, because these companies are spending billions and billions of dollars training. So to me, I don't know why if you're going to spend that much money, I don't understand why you'd want to get some sort of general purpose chip. But I think that you'd want to get a chip that is specialized for that. Now, I guess the counter argument of that is well, if you spent a bunch of money on specialized hardware for training, then you could only use it for training, and then you couldn't use it for other things. So I guess maybe some companies are thinking that, okay, we have this hardware and we can use it any way we want in a general purpose fashion. So it's we can use it for training, and then I don't know, but then we could use it to help run our web servers, or we could do some Bitcoin mining with it, whatever. You could do that, I guess. But still, I think that there should be a high enough of a critical mass of people who is hey, look, if I'm going to spend $10 billion on this training, you might as well get something that's specialized for the training.
I'm pretty sure that there won't be the optimal use of the hardware will be training for the next decade.
Yeah.
And they'll just be adding more hardware over time. Now, I don't know when successively new generations of chip come out, maybe some of the old hardware gets a little obsolete, but a lot of models actually can work multimodal on multiple versions of hardware. So I think the training will continue to be there. And a lot of companies have, like, for instance, we know we work with some pharmaceuticals and some medical industry, and they have very special privacy requirements in terms of their servers and how they need to be isolated. And so they're not going to want to put ML hardware in the cloud. They're going to want to have it isolated somewhere so that they can use their own data in their own, protect their patients' data and whatnot in their own premises.
So I suppose to solve some of these issues, you guys have your own Cerebras cloud to maintain peak utilization across all your chips, so that someone doesn't need to buy their own chip and have it sit idle after they're finished training.
Yes and no. We work with a company called Cirrus for cloud service kind of like behavior. Okay. I don't know that it's something you can just kind of like spin up an instance like AWS, because you need a lot of compute for it. Most people that are serious about it will and want to use our system will come to us, and we have different levels of service, from white glove, where we have people that handle your model and all that kind of stuff, all the way to, I know what I'm doing. I just want to run on a cluster of your systems. That points out another advantage I think we have. That's like ease of use. Early on, when you trained and then on a bunch of Nvidia things, you could tell it how many GPUs you'd want to use and do it. But it actually takes some amount of coding to scale out to a number of GPUs. Mm-hmm. And I think our CEO pointed out that, it might take many tens of thousands of lines of code to scale out to more GPUs, where for ours, you really truly just put another number in, and the user doesn't know how many boxes he's putting his thing on. As far as sharing workloads, our biggest customer, G42, is kind of the largest cloud provider in the Middle East. We've got 2 64-node clusters spun up from them, so it's 64 of our chips in each box. While they use it most of the time, there are periods of time where we'll have other customers that'll rent time on it.
So I grew up in the Middle East in Abu Dhabi, and I have a rough sense for the culture and like the interests there. They have a ton of money. They don't have as good of a talent pool as here in
Correct.
Silicon Valley. But I mean, I think most of the researchers are trying to go where they have the most compute. Yes. So it seems like a great play, yes. Very forward-thinking play. And these kings and the sheikhs and the rulers there are very aware that oil may not last them forever.
That's a good move on their part.
I think they were thinking about moving into clean energy at some point, but they've been trying to get into the tech game for a while.
Yeah.
And I think now it really makes sense for the Middle East to try to do something big, because compute is a very valuable resource.
Sure. I just hope the U.S. is listening and we decide that we want to have our own compute here as well, and not let it go completely overseas.
Well, I did watch the Cerebras AI Day keynote, and they mentioned a couple different nodes here: Santa Clara, San Diego, and one other location, I think. So,
yeah, the initial announcement with G42 included 3 64-node clusters.
How big is that? Is that a supercomputer? Is that maybe like just a big server?
How do I answer that? It's the equivalent of many thousands of GPUs, right? So
you could call that a supercomputer, though.
It's a supercomputer, yeah, 64-node. So what they said is we went into G42, and they had been, like you said, they're not an expert in ML, and so they'd been trying to get one of their models to work on a bunch of GPUs, and I'm not going to say how many because I don't remember the number exactly. And they've been trying for a bunch of weeks, several weeks to get it to run, and it hadn't finished yet. And so that we saw this opportunity. We came in with our box, or a bunch of our boxes, and we finished the run in a week, and it finished, and it gave them the accuracy they wanted, and they said, okay, we want this. Mm-hmm. And I don't think they're the experts at ML models. So someone at one of the hyperscalers like OpenAI or somebody could probably make a model better and more efficient and have finished. But most customers are not like that. Most customers, I've got a model, I've got data. Can you help me run it? I don't want to spend, hire hundreds of engineers to optimize that down to the point where I get every last ounce of. They just say, I just want it to run. Can we run it somewhere? And so G42 announced they're going to buy 3 64-node clusters. Now, the initial 64-node cluster, the press was quoting at about $100 million. I obviously can't talk about how much they really cost, but the first one was $100 million, and then 2 more after that, each at, say, $100 million per cluster. And then right after that, they said, we want 9 more 64-node clusters, or 6 more 64-node clusters for a total of 9 wow. At the moment, it's easier to have them here in the U.S. because you don't have to do export stuff. So we originally were going to ship all our systems over there, and then there's got to be so much import-export paperwork that we said, well, if we just put it in a data center here, there's 0 of that, and the access to it is the same, is immediate anyway, so why not just host it here? So we're hosting it here.
But to the point that Mark mentioned, energy is a big cost for training these models, and they're in the Middle East. They have all the energy. So I'm surprised that they didn't want to go through the paperwork to ship, what was it, close to $1 billion of chips?
I don't know for sure. I can imagine that somewhere along the line there will be systems shipped to them, and they will have on their premises. They will have nodes. It's a lot easier. I mean, it's a very complex system, so it's a lot easier to support when it's here. If there's we ship like 64 nodes, but we actually ship a number of nodes as spares to see it cycle in and out. If one of them shows a problem, we'll cycle in and out. And as you can imagine, because we're a wafer scale system, sometimes you find latent defects, and we have significant amounts of redundancy. And so we'll swap out that system, figure out how to repair that node out, and then it becomes the next spare there. So that's all fairly seamless for them.
So that was going to be one of my other questions. So when you're making traditional chips, whether CPUs, GPUs, on the scale of for a laptop, mobile phones, and even servers, they're pretty tiny. And you, I guess, etch out different. You take a die and stamp a bunch of different chips onto a large wafer, and see which one of those stamps looks good, and if any one of those stamped CPU, GPU die doesn't look good, then you kind of just toss it out.
That's right.
But with a wafer scale computing, you have a massive chip. I think it's maybe 10, 15, 20 times the size of a regular GPU. You don't want to throw that away.
You can't, because you would have a yield of 0. We know that the defect density there's going to be defects. It's back, one of the technologies that I worked with was like 16 defects per so many square centimeters or something like that. So there are defects. Silicon doesn't come out perfect. So they're going to be there. Now, whether they fall on a transistor or a trace or something that's going to kill you, that's a thing. But they're going to be there, and they're going to wipe out certain chips. So you have to have redundancy. And other companies have been doing this forever, right? Like memory companies, in order to get high yields, they have whole extra columns of bits that they can just redundancy out, right? If they find that there's too many bit errors on that column, they'll just take it out. And so they'll get a really high yield. And when you apply the power to it, they'll apply the redundancy programming, and anybody using it is none the wiser. So we have a standard size that is smaller than the actual total size that we use for redundancy to map out places where defects are.
So I guess the chip is bigger than it needs to be, so that if there are any redundancies in the middle, you would block out that row and column.
I can't talk completely about the technology, but suffice to say that there's plenty of overhead that we can map out. We can map out where the defect is, and still provide a standard size for the compute rectangle. I mean, software sees if you start with an X by Y rectangle of physical processing cores, software sees an N by M rectangle that's slightly smaller than that. And we have enough overhead to guarantee that the software sees that N by M rectangle and can run on it.
And so you take all these designs for this massive wafer scale chip, and you send it off to TSMC, right?
TSMC is our manufacturer. Yes.
Yeah.
They're the only guys that can do it.
Is there any constraint there? Because I assume everyone in the world wants TSMC's new 5 nanometer or even smaller. They keep going to 3 nanometer, I think Apple's at. Is there any challenges you guys face when getting the latest and greatest from TSMC? Or making enough chips?
Our quantity is so small compared to everybody else. I mean, a lot for us is minuscule compared to their normal daily throughput. So they don't really care about that. So the manufacturing throughput is not a problem for us. I think, in the early days of the company, we got access. TSMC wanted to do this, near as I can tell, and that was before I joined. I was employee number 30, so I joined about a year after the company started. But they had engaged with TSMC and got access to researchers there, which is pretty unheard of for a tiny startup, who wanted this technology to happen, and they made it work. And they continue. Obviously, it's a slightly different process because you have to make the connection between the die as a one or more steps in the process afterward, and that's different from what everybody else does. They just cut it up and put it in packages. So it's a slightly different process, and so we need to engage with them on that. But for the most part, it's the wafer scale part, I think, was actually the easiest part. But the much harder part is, if you imagine like your common video card and you've got a GPU on it, and you've got this, fairly large surface area to power it. You can put big fans on it. You can put power supplies all over the board. You can put decoupling caps and whatever you need to power that. When you have all the die on a single wafer, you've only got the vertical space above the reticle and below the reticle to power it and cool it. So you got to imagine you've got to power and cool a GPU's worth of chip, but only in this tiny little volume of above and below what that reticle is on the wafer.
Wait, you don't send the power from the sides?
No, it comes in vertically.
Oh,
and you can look on our website. We show there's blow up diagrams of power planes and cooling planes and things like that. That you can look at.
Yeah, it's crazy how even from the Nvidia's announcement like a month or two ago, most of the challenges weren't in increasing the chip performance itself, but everything that goes on top of the chip, like the NVLink connects and memory bandwidth, and actually even memory allocation to store all of these weights and move them around to these different GPUs.
It's a hard problem, and the mechanicals alone, our chief mechanical guy won an award from the French, I forget what institute it is. There's only like a couple hundred of people that have ever won this award for the mechanical design on our chassis, because it's so unique and it's a good design.
That's cool.
Yeah, cool.
So one thing I'm kind of curious. You mentioned that there was a lot of paperwork to ship the chips to the Middle East.
I don't know for certain. I'm not involved. I'm an engineer and I'm a local level, so I have absolutely no idea.
Yeah.
I just know that if you look at the government, you have to get waivers and things for anything you want to ship over to the Middle East. It can be done. And there are countries you can't ship to, but the Middle East is one where you have to get waivers and things for.
Yeah. Because what I wanted to kind of touch on is, I'm just sort of curious if you've heard anything about, I think like the U.S. has like their CHIPS Act, where they have been trying to bring like a lot of computing into the U.S. I think like TSMC built a plant here. I know they've been like giving a lot of money to a bunch of different companies. Have you noticed anything since like, I'm like a little bit farther away from hardware than you are? Like, I don't know if you like.
Well, we hear stuff. I mean,
that
none of it actually relates to our business at the moment, and it won't for a really long time. But because it's a really hard infrastructure to build out. This special. Not only is there special, like you can build a fab, but one of the things that TSMC has is they've got packaging companies and part supplier companies and testing companies and all this collateral business around their fabs that you don't just build a fab, because then you have to ship stuff here and there to get it packaged, to get it tested, to get it, and that takes time and money to do that. And everybody wants things really fast. So TSMC is truly optimized in terms of they have a whole infrastructure, much like Silicon Valley is for startups and things. You've got a whole infrastructure in place that's really hard to replicate. And so they're going to have to build fabs, and they're going to have to grow their own infrastructure around it to do all the other hard parts, which are, packaging and testing.
So imagine you were like, like a government official in the United States, and you were trying to, bring TSM, like a TSMC like company here, or like that infrastructure. Like, what do you think you would do? Like, because I think that a lot of people may be listening to this. I mean, hopefully some government officials are listening to this podcast, and they're thinking like, what should be done? Like, what would you do? Like, if you had like a magic wand and were you had like, let's say like unlimited funds, and you were trying to, bring some chip manufacturing into the United States. I think like in the United States for sure we do like all the design. A lot of the design is done here, but a lot of the manufacturing is done in Taiwan, right? Like, what would you do? Like, bring that here?
I'm the last person to be an expert on this, so anything I say is going to be just totally off the cuff. I have very little expertise in this. I mean, if you had infinite money, you just build it and let people use it for free, right? So the problem is exactly that. You don't have infinite money. Somebody somewhere has to see some return on investment for building this out. So
right, but I think that in a certain sense, right, like the money part aside is like, you could give me $1 billion and I would have no idea like even where to start, right? Like I would just start asking around, like, guys like you, like, hey, like, where do I start like building this? Because I think that like it's like I just like would have no.
You would
find
like
experts, my skill set, right? Like I
find
look
experts,
for them.
find
right?
experts
So, like,
would find experts.
Exactly. So I think that like in Taiwan they have like a lot of people who like know what they're doing when it comes to building the chips, and I don't know if like we have that skill set here as heavily in the United States. Like
I think you'd have to throw an enormous amount of money at it.
Yeah,
that's all there is to it, and. It's like any kind of technology you want to succeed. Like take solar panels, for instance. You have to put an amount of money in it so the product reaches an economy of scale to where it sustains itself.
Right.
And that's a really hard thing to do with chip manufacturing because the investment is really large, and then you have to have the throughput to sustain it.
So in a certain sense, like, in order to do that, if you going back to like the thing, if you were going, you'd want the fab, but then you would also want to have all of the things around the fab. So like, what are the types of things that like you would maybe need in a fab to, that like, for like a steady supply of things? Like I know one thing is like ASML. They have like the lithium machine. Like I assume that's one thing.
Like the only company that makes that.
Yeah, I assume there's like a bunch of other stuff that you'd need too.
I think they're going about it the right way. They're encouraging companies like TSMC to build fabs here and giving them tax breaks and whatever in order to sort of like seed that industry. But I mean, you've got engineers and technicians that you have to train. You've got other infrastructure that has to build, like I said, and you just have to I guess you would have to pay attention to all those things. I would say make sure the soil is fertile. Don't just throw a fab in the middle of the desert because there's sand there, right? You got to make sure that there's going to be, housing and engineering, schooling. You got to make sure they're graduate students that can do the research. You got to provide all this stuff, all this fertile ground for the seed to take root. Otherwise, it's just Congress throwing money into a hole. Without taking care of all the stuff around it.
Yeah, and I think that's like a really important part, because I think it's very easy when all you have is money. It looks like the money can solve everything, but in a certain sense, like the money is useful, but like all these things that you mentioned, like the right people, the right infrastructure, having the right location, for example, if there was a fab here, let's say in the Bay Area, I think a lot of people would maybe want to go work at it, right? But if you're going to build in, let's say, I don't know, like rural Alaska, where it's really cold, so you don't have to worry about cooling, right? But it's dark like 4 months out of the year, and then in the summer, it just like the sun never sets, so you might have to really do some convincing to get people to move there. So.
It's even more than that. There's a certain serendipity to it as well. I mean, people have tried to replicate Silicon Valley in other places, and my thinking is one of the reasons it's really hard is, there's a critical mass of talent here that if somebody takes a job at a startup and the startup fails, they can go to another startup and another startup and another startup, or a big company for a little while, then to a startup. Whereas in a lot of places, if there aren't enough startups for them to risk their career on, if they go to a startup and the startup fails, they don't get to go anywhere else, right? There is another startup around the corner, right? And so to build up that critical mass just happened organically here, and it's really hard to make something like that just happen. There's I don't know, kind of random things that have to happen to make that work that you might not be able to predict.
Yeah, that's very true. I mean, I think like at the Bay Area, there's so many smart people, like highly concentrated in this area, and I think that's due to like a ton of reasons, right? Like, I mean, Stanford's right here, Berkeley. I mean, now all of the big tech companies. You have all the money here, right? Like, you have like all the AI money, all the tech money, right? And you're all within like a pretty small area. Like, I mean, you could probably throw a rock and hit a software developer in this area, which which is bad for the software developer that just got hit by the rock. But it's good if you're looking for like a co-founder, you're looking for money, and I think it's like it makes it a really like somewhat magical place.
Sure, absolutely. And starting with like Fairchild and National Semi way back in those days, they had a ton of really smart engineers that came here and settled here, and it just grew from that. And I know tons of stories of people that have been here for a long time talk about, my dad invented that, and as a kid I got to play with that kind of thing, and that's not true everywhere.
Are you originally from this area?
I'm from Rochester, New York.
Oh, okay.
And then college at Northwestern in Chicago, and then I did a stint several years at Raytheon Company on the East Coast.
Raytheon is military?
They are. They're kind of funny vertically oriented thing. They had a beach aircraft they own. They owned the Amana radar range came out of that. It's called the radar range because some engineers put their lunch in the radar transmission cone, and when they took it out, they realized it was warm, and then we're like, why is that? Well, it turns out that the radio waves will stimulate water, molecules, and that causes them to heat up. And lo and behold, Amana was formed, and the radar range was born. And so there's a bunch of, and they had own publishing companies, but primarily military stuff, components for planes and things, and radar, which is where I kind of cut my teeth doing radar.
I guess what made you want to leave that and come to Silicon Valley?
I wish that I had come to Silicon Valley right out of college. I really do, because there were so many startups like at a company like Raytheon, and it was great working there because they're big enough that if you're kind of any little bit motivated, you can take the time to learn technology and things, and that's really awesome. So I learned about radars. I worked in Virginia Beach on a radar for a long time. I wrote operating systems, all kinds of board design, all kinds of really fun stuff. But Silicon Valley had this startup mentality, and this is purely a financial bit because people would come here and startups would be, you'd get some giant chunk of shares to begin with of ISOs, and they would keep those really low until right short of IPO, and then a company would IPO and they'd be worth, you'd be done, right? In a heartbeat, you'd be done. It's much harder now. When I came here, the rule was, one startup might pop really well out of say 10, 2 or 3 might kind of linger a while, and 3 or 4 would just kind of fail. But you knew in a couple of years, in 2 or 3 years, whether the startup was going to fail, you can go to the next one. And if you happen to place your bet at one of the big ones, the ones that popped big, you're kind of done. And that's a kind of a roll of the dice, whether that can happen or not. Because I've been at startups that I really liked. I thought they were going to do well, and they didn't. Who knows why? But if you're trying a bunch of them, eventually, hopefully, you hit on one that happens to do really well. And if I had come out here earlier, I think it would have increased my probability of not having to work at an earlier age, which is kind of a golden thing, I think.
So, how long have you been at Cerebras?
I am employee number 30. I've been there 7 years now.
7 years. So you said within 2 years you'll probably have a good idea of whether or not this startup is going to succeed.
Well, so let me. When I came to the Valley in '92, it was what I was describing before in terms of its startup. Now it's nothing like that. The Valley's been through a couple of expansions, expansions, and contractions, and VC money is much scarcer in a way. The probability that a company is going to IPO has gone way down. More companies are being acquired at the time, and if you go back to '92, you're in a startup, you get 100,000 shares. The company goes public at $10 a share. They go to $100 a share. You're done. You stop working. That mentality doesn't happen here now. You're not likely. Maybe one in, I don't know, 50 or 60 will pop and do something interesting, and the rest will get acquired or fail. And now we have companies and venture capital and stuff gaming the system. They don't necessarily care that the fundamentals are good. If they can cash out, early, regardless of what the fundamentals are, they'll do that, right?
So taking a step back, you mentioned Cerebras doesn't make as many chips on the scale of like Apple, Nvidia, AMD. For TSMC, you guys are a relatively small customer. You guys focus on a specific niche, specifically trading. What do you think the future is? Is this your retirement plan? When do you think Cerebras will have a big enough market to say, okay, let's IPO?
Who knows? I mean, I think our CEO made a really wise comment. He said every CEO at a startup should have a price in the back of their head that they will sell the company at. If somebody walks in and writes a check with that many zeros on it, they'll take it. So you do what the market tells you to do, right? You do what's right. In order to IPO, you need to have fundamentals down, I think, and I'm still a believer in that. You need to have, some number of quarters of profitability. You need to be able to look to the future and see that you're going to be profitable. You have to have more than just one customer. There's a bunch of things, fundamental things, I think you should have in order to IPO and not tank. Right, you want to IPO and stay sustainable.
So what is that number for Cerebras? Because I think right now, you guys are maybe at your last funding round valued at something like $2 to $4 billion or something.
You would have to be psychic and look into the CEO's mind to figure out what that number is.
I just have to add a couple more zeros to that.
But if you compare that to Nvidia's market cap, they're like 1,000 times.
Sure.
Bigger than Cerebras. And that seems like
I wouldn't even begin to guess. That's just not something I can speak to.
I think that means there's a lot of room to grow, though.
The market's big enough for a lot of players, actually. Yeah. I believe that's fundamentally true. The market's big enough for a lot of players, and I certainly don't begrudge Nvidia their market share. They were clever enough to do CUDA in the first place, not even aware that this was going to become a thing. But they were a crypto for that matter. They just saw that, hey, this is an interesting thing. If we release it, it's kind of like a Field of Dreams thing. Build it and they will come, and they did. They came in enormous numbers.
But I think we were talking in the past, and you mentioned that you can run CUDA code on Cerebras hardware.
No.
Oh, no?
No.
Oh, okay.
We've got our own custom assembly language.
Oh, I see. Okay. Okay. Gotcha. But like, if I had RE things in CUDA, I could like convert it over to.
No.
Oh.
So essentially, models are described. It's interesting because and again, I'm not an ML guy, right?
Yeah.
I'm just kind of associated with ML guys. My understanding is that models are described in TensorFlow or PyTorch as a series of layers with certain operations that happen at those layers. And really, the very top level of that is describing a network, which can be abstracted and broken into smaller pieces, which are then mapped to kernels that do those operations and are balanced on the hardware that you're running on. Like for instance, a big part of the problem is if you've got a layer that is twice as fast as another layer, right? It's going to finish its work before the next layer is ready for it. So maybe what you do is you use half the cores for it. You make them do them twice as slowly, so that when that layer is done, it exactly matches the throughput of the layer after that. And so this is a job that software does in balancing kernels, not just the selection of the kernels, but actually how many of them and where you place them, so that the data flows maximally through the thing with a few bottlenecks.
So I know NVIDIA has had CUDA for a while, but I think that's still kind of a little cumbersome to work with for software developers. And I was reading about Bend, a new high-level programming language similar to like Python-esque, where you describe this concept of threads, and it just handles all this parallelization in the background.
Yeah, good for them.
Not just with a single GPU, but across like massive workloads. So what is, I guess, Cerebras' equivalent to CUDA, and how do you guys make it simple? I know you weren't an ML guy, but if you had
we have just like them, we have kernels that map to our assembly code. We have operations that map to our kernel assembly code, and you just have to do that mapping. And I guess the difference is that it's not our assembly code is not open source. It's not something you can just look at and write your own code for. All of it's now controlled by us. At some point, probably they'll have standard developers kits out there. I think there is a standard developers kit that you can use to. I think you can actually just become a developer and download it, but I'm not 100% certain of that. But anyway, there's, they're not going to stand still. They're going to optimize. That's great for them and the whole market. Making programming easier is a job everybody is kind of working on, I think.
So what's your stance on the whole closed source versus open source, both with I guess the software stack and the hardware architecture design?
Both have their places where they're useful. I mean, it's like, let's take a more abstract question like C versus Python, right? They're two very different languages, but they both serve very different purposes. There's some things that I would absolutely want to code in C or C++, and there's some things that I would absolutely not want to code in C or C++ and want to do in a scripting language like Python. And so it's the same kind of problem. There are things that you want to do one thing with, and there are things that you want to do with a different tool, depending on what your use case is and how fast it is. And so open source, great stuff. It has enabled, let's just take an obvious example. You want to run a server and you want to run software on a server. Well, let me tell you, all of them are running as some kind of free version or relatively free version of Linux. Of Apache and Linux on them. And you want to run compute, it's probably all running Linux. And there'll be some layers of open source code on top of that to get it run, VMs or what have you. And so that's all really great. But a long time ago, I worked at Rendition. It was a graphics company, and one of the early graphics companies. And back in those days, drivers were incredibly different, and difficult. Like, people probably less frequently hear the acronym BSOD, or Blue Screen of Death. Microsoft Windows would crash all the time with this thing called the Blue Screen of Death, and it would just be a crash, and it would be fatal, and you'd have to reboot. And they got an enormous amount of heat for that. And 99% of the time, it wasn't anything that Microsoft wrote. It was a third-party driver that did it. It was your sound driver or your graphics driver or some other kind of piece of driver that was... And so they created this whole certification methodology called WCL to help certify drivers so they wouldn't be shipping things, or ultimately computers wouldn't crash, right? And that's kind of a goal. Even though it's not their software, they want to enable... So that you have to lock down some stuff to prevent instability. I mean, and that's kind of where closed source stuff happens, is you lock it down to prevent instability.
I mean, that's one of the big reasons why I've loved the Mac for a long time.
Yeah. I use the Mac because it's got Linux underneath, and I can open up a shell and I can do all the same stuff that I could do pretty much on a Linux shell. And even though Microsoft has tried to create a shell to do that, they have some very fundamentals like piping. Piping in a Linux shell is piping between multiple commands, but in a Windows terminal window, it's not. You can't just pipe stuff the same way you would. It says, "Oh, this command doesn't accept that," or argument, and it's really like everything that you want to do, you have to relearn for their shell, right? And I'm not saying it's wrong or bad. I haven't used that much.
I think it's just that most computer science students learn to work with Linux when they're in school,
because it's free,
and then transfers easily to Mac versus Windows.
And that was Apple's brilliance when the Macs. I remember when the Macs first came out, which is dating myself. I remember seeing that printer. I remember seeing a Word document, and it had pictures in it. Now, it may be hard to believe, but that was a really hard thing. Like when I started my career, you hand wrote your document, you handed it to the admin, and she would type it up.
Wow.
Right? And then if you had figures, you would reference the figure, and you would have an attachment with all the figures at the back, and they would staple it to it, and they would copy it in a copier, right? And when Macs came out, engineers could then write their own documents and embed the figures right in the document, so you'd see it right there. And it would print out on these crappy little dot matrix printers. But at the time, it was like, oh, it's all embedded. And so like the admins went from one admin per 5 people to one admin for a whole department, because all the engineers were typing their own documents and editing them and going through cycles of editing much, much faster and much, much quicker. And so the whole sort of like admin pool went, got kind of decimated by that.
So computers took their jobs?
Pretty much, yeah. But I mean, think about typewriters, right? Imagine your IBM Selectric vendor, right? the moment computers came out, all the typewriters went away too.
I'm sure it wasn't an overnight phenomenon.
It was pretty close to. I mean, a couple of years, all the once computers like the Mac came out, all the typewriters went away.
Do you ever worry that with these increasing technology gains, with like AI, that a lot of people are just going to lose their jobs? Like it could be all of us.
That's a great question, and that's kind of one of the things I was hoping to talk about on this podcast is some of the more optimistic views on where AI might be taking us. And one of them that I used just the other day was, a while back they did this paper with they got together few dozen radiologists, and they were looking at brain scans, and they were trying to identify tumors. And then they trained an AI to do the same job. And they got the few dozen radiologists, I think, got a score of like 96%, but the AI got a score of 95%. Right. The difference is that, radiologists take a long time to train and have a very large salary, and they need to be on staff at every hospital. And at small hospitals, it's not possible to do that. But if you have an AI that's just almost as good as a real radiologist, every doctor everywhere in the world can run a copy of that AI. And for zero time and very little energy and cost, can have an expert's view of an X-ray. And we're talking doctors in, poor countries, doctors in rural neighborhoods, small clinics can get access to world-class radiology interpretation.
Yeah. And also, I think that would just help doctors and radiologists just save time as well, right? Because before, if it takes you a lot of time to, I don't know, I'm not a radiologist, but like I would assume that it probably takes some amount of time to just, look at the image and just try to like make sense of it.
Right.
So I don't exactly know like how long that takes, but maybe a radiologist can do it in, let's say, like X amount of time.
Yeah, minutes.
Minutes, probably maybe like tens of minutes if it's something complex. But I would think that the AI might be able to do it within seconds or like milliseconds as well.
Sure. And so you could still, it won't eliminate the need for radiologists, right? Because there'll be some questionable ones, but the AI is a little uncertain. And so you kick that back to your team of radiologists.
And also, I would assume that the radiologists do more than just interpreting the images, because they have to go and run all the machinery, make sure they don't like burn you with ultrasound, like give you like cancer from all the X-rays, right?
I'm not sure that's the radiologists. I think that the nurses in the radiology lab are doing that.
Yeah, I think that's true. Although my understanding through talking to some like radiologists is that like there is quite a bit of training in order to like actually run a lot of that equipment.
Yeah. So I think you run the danger of devaluing certain jobs because they can be done better by AI. And then if nobody goes into radiology, you lose the expertise, right?
Right.
And that can be problematic. And so I heard this interesting quote the other day. It was that, and I don't believe that AI is going to replace jobs wholesale the way there's fears of it. And I think though, the quote I heard was, it won't replace jobs, but a person using AI will replace a person who doesn't use AI for the same job. And I think that's true. AI has its best, I think today, its best use case in being supplemental to work that people already do to make them more efficient and make them, maybe take some tedious parts out of their job so they can focus on more creative and interesting parts of it. And that's my hope.
Yeah, I think that is probably true for a vast amount of jobs. Although I think that depending on the job, it may just completely eliminate it. So, for example,
sure,
not necessarily like AI, like all jobs, but like, for example, I think of like truck drivers, right? So it's like if your entire job is just driving from point A to point B, or like Uber, taxi driver, right? Self-driving cars, then like that complete population of people may be out of a job and be replaced by like a Waymo self-driving taxi, right? And
maybe at some point.
Yeah.
But number of deaths will go down and things like that on the road, because I think AI will be better at driving ultimately. And maybe that truck driver, maybe you'll need to have a truck driver in there in the vehicle, just not necessarily driving. And maybe the truck driver will have a train of 2 or 3 vehicles behind him, which is a company that I think has been, in the works before that, from years ago. And that truck driver can then do something more productive during that time when he's watching they're manning the truck.
Yeah, I think that's true. And I think that like in the short term, we'll probably definitely see something like that. I'm just thinking like, let's say not in the next 5 years or 10 years, but let's say the next like 50 years or something like that, when I think that like we'll probably be able to agree that in 50 years from now, like probably many people won't, like driving might even be like a lost skill.
Yeah.
Practically in the next
all bets are off at that point.
Right,
Yeah.
So like, what do you think, like if the AI becomes smart enough to, let's say, replace all the jobs, like what jobs or like what do you think people will do in 50 years from now? Like, if, or like 100 years, whatever, like sometime like when the AI is able to be smarter than like any human to like the point of being like a god, which I think could be the case in the future. Maybe.
Well, let's just go there a little bit. Let's just go there a little bit, and I'll outline a couple of really interesting scenarios. One is everybody will be then free to pursue whatever they want. Like imagine people, like AI will probably be running universities. Imagine people learning to get degrees in philosophy and music and math and science and all kinds of really interesting things that they'd have time to study and pursue as hobbies rather than now clocking into a 9-to-5 job. Maybe somebody wants to spend their time making music or something like that. And then all their needs are taken care of and they can just make music if the AI isn't making it for them. I think the biggest fear is though that things get done because people have influence and money to do them. And the people traditionally in our species, the people with the influence and money have always wanted to control the technology and the things they've done. And so you get a very stratified society. And so if AI can do everything and say a lot of people are out of work, who's going to provide for them, right? Like suppose a robot, you need a robot, right? But are the people that making the robots with their energy and time and influence and whatever counts for currency at the time, are they going to just give you that robot, or are they going to demand something in return for that robot, right? And so technology has traditionally always found ways to stratify society. And so we as a species have to find ways to counteract that tendency that we feel everything is so scarce and so dangerous that we want to protect ourselves by accumulating as much as possible, by having as much as possible, by being as having as much, let's call it defense, right? would be that money to hire people to literally defend you, or big houses where you don't have to talk to people, or any number of things, or enough financial gain to hire lawyers, or whatever. People have always been really afraid, and so they accumulate wealth and power to defend themselves against things that aren't really zero-sum games, against things that, are, as a society, we can figure out. But deep in our reptilian brain, we're programmed to believe that things are scarce and that there's danger around every corner. And so that leads people to be very defensive and and want to hoard things. And by hoard, I mean wealth and power and other things at the same time. And so we have to crack that nut in society, I think, too. And that's a nut that, philosophers have been trying to solve for millennia.
Yeah. It's interesting because you mentioned like wanting to hoard wealth and power and whatnot. But in a certain sense, I can envision like a world of abundance, like a complete abundance with AI. But
that's the Star Trek world, right?
Yeah.
Where everybody, all their needs are met. They can do whatever they want to do.
And I think it's really hard to make sure that like, not to say like that abundance will be distributed like equally necessarily to everybody, but to like potentially like raise like the base quality of living for everybody. Yeah.
And that's kind of the thing. If you can find a way to, it's not enough to raise the quality of living of the lowest 50% an increment, where the quality of living of the highest 5% gets raised a million times that, like you can say, well, healthcare has been better for everybody on the planet, for everybody. It's gone up for everybody. Therefore, let's not begrudge the economic discrepancies that are occurring for other reasons. But I'm like, no, well, I mean, this is the question. Should there be billionaires? Should there be trillionaires? Is there something, that like if it's okay for people to accumulate wealth and power, is it okay for one person to have it all? Like if you take that to this ridiculous thing, is it okay for one person to have it all and everybody else is poor and serving them?
Yeah, I think that we'd probably agree that like taking it to that extreme, like if one person just had all the wealth, that would not be okay. And I think if that happened, then all the other billion people or whatever, if there's one person and the 99 people had nothing, right? They would just go beat the crap out of that person and be like, it's mine.
Well, the counter argument is if that one person controls all the robots, all the wealth, all the technology, then the 99% can't do anything.
That's the problem, right? And we see societies throughout all of time being that way, from kings to popes to oligarchs to autocrats to, we've seen societies go through that same struggle all the time, where the one person makes a grab for as much power and wealth and subjugates the rest of society. Look at North Korea; it's a perfect example of that. And you know what? North Korea's been there for 50 years, right? And it hasn't changed, and I don't see it ever changing. Right? I mean, people are not going to rise up.
I think authoritarian societies are awesome when they work well.
You're trying to say a benevolent monarch is better than any other system. The problem is you can't always pick the benevolent monarch.
Yeah.
Right? You have to find some way of succeeding. Like imagine. So here's the scenario. Imagine North Korea, and imagine the whole world that way. The whole world, right? There's no democratic country trying to balance that out or trying to reverse it. And that was the whole, I think, fear for the communist scare, was if the whole world is that way, everybody's repressed, and there's no way to turn it around. If you've deprogrammed everybody and you've given them such propaganda all the time, and you've beaten out of them any thought of resistance, and the whole world is that way, what can you do? And so that's why this enormous amount of resources was put in to try to go up against, I think, at least I'm not a political scientist, to go up against communism, because they didn't want the whole world to be that way.
I guess democracy prevents the worst case scenario, but there is a lot of friction, and especially with our capitalist version of democracy, the income inequality is just like rapidly expanded, especially since the pandemic. I think the amount of wealth that was created in the top 1% was just in the double-digit trillions. I think
it's been 30 years. It hasn't just been since the pandemic. I think, although that exacerbated a little bit.
Look at a short time frame of 2-3 years, their wealth doubled, if not more. The top 1%.
We should get back to AI, but along those lines, there was a time that I understand when the multiplier between the highest paid employee and the lowest paid employee was like 30. So highest to lowest. Now, the multiplier between the average employee and the highest paid employee is 300 to 400. So it went from highest to lowest, which means everybody was in between of 30x, to average to highest of 300, 400x. I do consider that a failure of our current economic system. But I'm not a political scientist, so
same. But the reason I was talking about that is because that is the one end of this extreme, where the other end is, yes, things have gotten way better. Healthcare has improved. We have access to amazing technology. And you've been here in the Bay Area since '92. So I can't imagine the amount of progress you've seen here, and how quickly things are moving now. And to give the billionaires credit, they're trying to make access to these technologies as easy as possible. I mean, GPT-4o is now free for everyone, everywhere in the world. Same with Google's Gemini. So I don't know if we could have imagined a time 20, 30 years ago when we would have had this relatively super intelligent being in our pockets for free.
The vast majority of people working have no need for anything like that.
You don't think it's helpful day to day?
Not to the maid cleaning houses, or to the garbage collector picking up garbage, or the farmer in the field, or none of that stuff. So it might be helpful to the corporation that has farmers in the field, but not the guy out there picking.
Not as an employee, but just as an individual. I think I've found myself turning to these LLMs more often than going to a search engine. So just for my personal information, I think these are incredible tools.
Yeah, but I think most people don't care. They're not searching for stuff, right? Like that's one of, I think, the conceits of tech people, and I have it too, is we think that because it can make our lives so much easier and better, why is it making everybody's lives so much easier and better? But it's really hard for us to put ourselves in the shoes of, the plumber or the we don't care about that kind of thing. It doesn't help their job hardly at all.
So what do you think is the point of life then? What is the purpose?
Oh man.
And can LLMs help?
Well, and let's get to there, because that gets us into some things I really did want to talk about. My personal philosophy is one of the point is to decrease suffering in the world. That's part of the point. At least that's one of the edicts I go by, because it doesn't require any kind of supernatural belief. It's just something you can see and act upon. And I think there's a lot of opportunity for AI to help decrease suffering. And one of the ways you do that is by trying to filter out information that is detrimental to the advancement of society. And I've talked about a couple ideas in the Meetup on how to do this. One is to suppose you trained an AI to recognize when someone's trying to convince you of something that is they're using either logical fallacies or using some kind of cognitive bias trick. Maybe we can train AIs to detect, hey, what is the real argument here that this person is making? And what is this sideways attack to try to win you over or get you to believe or follow them that they're making, that has absolutely nothing to do with the things that you want in your life? It's just a demonization or a inciting of fear or some kind of anger to get you to believe something so that they can convince you to vote the way they want to vote, or to act they want to, or support who they want you to support. And
I can see like a future version on a phone call, similar to how in Gmail you get an email and it marks it as spam. So if you're talking to someone and they have a conversational pattern when they're trying to manipulate you, it marks that as, okay, this guy's being manipulative. Watch out.
Yeah, no, exactly. And really, the goal isn't necessarily just to tag people and punish them. The goal is to get people better at recognizing it, so that they can support the people who are more um, less disingenuous, that are more straightforward in what they're saying and how they're presenting their argument, and one that doesn't trigger some kind of anger or some kind of disgust or something like that. Like, disgust is a really powerful way for a politician to demonize a group of people. And there was a recent study that talked about how just calling someone a name, just saying something derogatory about them, makes it more likely that the people who've heard that will believe something worse. Right? So if you say, oh, that guy...
And it may not be true.
And it doesn't even have to be true. It just because of our cognitive biases, it just primes our brain to think, to associate that person with something negative. So the next thing you said that negative, we associate with them, and you can just ride that all the way to the point where you're hating somebody. And I think that's a trick that evolution has paid on us, because it favors treating everything as in a negative way because you survive better. But we're not animals anymore. We don't need to do that, but our brains still don't know that, right? So, if the grass is rustling, 99.99% of the time, it's not the lion, right? It's just the wind in the grass. But if you always assume that it's just the wind in the grass, the one time it's a lion, you die, and your genes get out of the gene pool. And the next guy that assumes that it is a lion more frequently will survive more frequently, and those genes will carry on, and you'll have a tendency to an evolutionary tendency to give more weight to negative things than positive things, and that's kind of the way I think our brains are coded.
So you talked about a bunch of things that I wanted to touch on.
Sure, let's go.
Well, one of those important conversations, which is poignant for everyone, I think, is the upcoming elections and how people can use LLMs to maybe generate more propaganda, do like mass manipulation at scale, create like misinformation, because it's so easy to generate content, both text and images, and now soon maybe like video footage too.
And we won't even know what's going on because they will send it directly through the platform to the person receiving it. And that was one of the I think the takeaways from the whole Cambridge Analytica thing, was that I think they discovered that upwards of 3 to 4% of the population is prone to believe in conspiracy theories. And we now know, and back then they were saying, well, could it be that bad? But we now know that it's actually worse than that, that up to 20 to 30% of the population can believe in conspiracy theories without any problem. We also know that it only takes they also proved that it only takes 1 to 2% of the population to swing an election one way or the other. And they practiced it in a number of countries, including Brexit, including the 2016 election. And while I don't think you can say that like it made the election, if it had not been used, I think the election would have gone the other way. But there's a number of things that you could say that about. This is just one of them. And in this upcoming election, I'm not seeing a lot, and I don't know why. And I'm hoping it's because there are more guardrails that technology companies are putting on to prevent that kind of behavior. Mm-hmm. And I'm hoping it's not because they've just got better at hiding it. But we do see on social media platforms this just enormous amount of fear and rage and hatred and all these things that are stoked partly by information that AI could classify as, hey, look, this is not in your best interest. This is not in our species' best interest, let alone our country's or our democracy's best interest.
Let's say you were narcissistic megalomaniac. How would you take over the country if you were going up for elections?
A narcissistic megalomaniac. You'd have to. So, like, if you look at the, I'm not sure I shouldn't tell you this.
Well, I think
maybe as a way to prevent it. Yeah. And I would encourage your listeners to look at this and maybe look for ways to use this to prevent it. But if you look at Wikipedia, there's some 230 cognitive biases that are listed in there. Mm. And, marketing people have been really good at getting you to do something because of cognitive bias. And like, for instance, think smoking, right? Mm. Smoking was made cool by having movie stars in movies do it and having television ads saying it's really cool and all the cool kids are doing it and stuff like that. They were marketing fake, candy cigarettes to kids and whatnot to make it cool. And And that was all marketing. And it was just being cool.
Be fair, smoking is also just, it sells itself. It just feels so good in the short term, and the long term
But why would you even start if you knew that it was long-term detrimental? Why would you even start? And the reason is because of marketing.
That are long-term detrimental. Like I eat like a donut because it tastes good, but I don't know if you fat.
Absolutely. Yeah. So, but anyway, my point is that these marketing people have long known that they're cognitive bias. If you look at some of the ads from the 50s and 60s, you're selling a radio and you put a sexy woman on it. Look at the airlines, the way they used to dress stewardesses, right? They know that these cognitive bias things can influence you in favor of what they're selling or pitching or whatever. But imagine an AI that uses not only that particular cognitive bias, but all of them. You can train it, and not only all of them, but they have a profile of you. So they know what works best just for you. And they can emphasize the ones that will convince you of something, stoke your fears, your hopes, or your whatever, playing on any possible cognitive bias that they can find that does it. And convince you to do literally whatever. I mean, convince you to, storm the Capitol, right? To believe that the election was stolen and that you should go fight for democracy. I believe that a lot of those people really believed that. They really believed that the election was stolen, despite enormous amounts of evidence. But because the tribe they belonged to and the leader of the tribe they belonged to told them that it was true, and they're loyal to their tribe, they did that in a lot of them in good faith, believing that, hey, this is wrong. We need to turn this around. And so we need to find ways to ferret out that kind of truth or the possibility of falsehood in those narratives. And AI is uniquely positioned to see, like I said, when I was talking about cognitive bias, to detect when an argument's being made, an ad hominem attack or a straw man attack or some other kind of enraging thing is being made that isn't really the point, but it does get you inflamed. And I rather than just say, these people are bad, they're doing these things, I would say, hey, it's the population that votes for somebody. You guys need to learn how to recognize this stuff so you're not conned, right? So you're not conned. There's a science fiction story where one of the statements the guy made was, people will believe either what they hope is true or what they're afraid is true, right? And oftentimes the truth is neither of those two things, and maybe somewhere in the middle. But if you can stoke their fears and hopes, you can get them to believe what you want them to believe. And that's the promise of, a lot of religions, a lot of politicians. They hope it's true that this is happening, or they're afraid it's true, so they do that. And we have to get. I think I would like to see people learn how to recognize what the truth really is, and understand, and maybe AI can give them some guidance as to how they can recognize that, what to look for. If you had a speech, for instance, and you could mark it up, or even a website where you point a URL to the website, and the website would mark up all the things that were, cognitive bias arguments, and even just the difference between editorial and news, right? News is a presentation of the facts of the things that are happening, right? There's things that you can prove or disprove. There was a hurricane, there was a riot, there's a fire, all these things are, and they may be false, but they're at least things that you could prove true or false, right? From editorial, which is, there was a fire because, PG&E is a terrible company or something crazy like that, right? Those are editorial. They're not. But and if you could run text or speech through this AI filter, and you could see that 90% of it are things that could be proven true or false, just say that's news. Whereas 90% of it is things that are just, opinion or just something that's neither provable, then it's editorial. And it started way back in the days of Rush Limbaugh, where he was presenting as news, not only editorial, but whenever he was taken to task on things that he said they're wrong, he said, I'm just a comedian. This isn't news. Why are you guys taking me seriously? So under that guise of being a comedian, he would be presenting things that people were taking as news, which weren't. And we saw that on Facebook as well. Facebook didn't want to be, a lot of people were spreading news, and I air quote the news, that they thought was really news, but it really wasn't. It was editorial, or it was some other kind of opinion that they would claim is truth. when it really wasn't. So you could have an AI kind of like try to differentiate between editorial and news, and maybe people would learn to detect what's news and what's editorial and put it in a proper way instead of just going on and consuming media thinking it's all truth when most of it now is editorial. Much less of it is actually news, and most of it now is editorial. And news is a much more important way to be informed because it's based on things that happen, facts and whatnot.
Yeah, I think that this would be a really interesting project to build. So for those that are listening that want like a fun little weekend project, I feel like this would be a thing that you could build, maybe a nice little Chrome extension where you can go and look at all the articles that you're watching. Maybe like, I don't know, if you like as a bonus, it could even help like interpret YouTube videos or whatnot to look for the cognitive biases there. I think that this could be a project that could probably be built within a couple days if you know what you're doing with the help of AI.
And if you want some more exposition on this, contact me through Shashank or Mark, and I'll be happy to work to kind of outline more of my thinking on how this can benefit our humanity. Actually, I would say democracy and culture. We have a ton of obligations in our lives. We have obligations to our family. We have obligations to our city, to our high school, to our college, to our state, to our country, to the world, to humanity, to nature, and everybody has to balance some of those obligations out. But I think the obligation to humanity, which is a little different than the obligation to, say, nature, is to try to get people recognizing real truth in things and being able to move society forward rather than backwards.
I agree. I think that it's really important that we can all at least get the same facts right. If people are disagreeing on the fundamental things that have happened, then it's really hard to have a meaningful conversation if you can't agree on that. And I think AI could, help get people at least on common ground and avoid any biases. Because, like, I know for a fact that I am, like, impacted by biases all the time. And, like, it's really, really hard. So, like, I think that you mentioned that like a large percentage of the population believes in conspiracy theories. And I think that like to defend them for a moment, I think that it's really easy to get swept up in potentially conspiracy theories, because the problem is like there's a lot of things that I think like in the past were told as like the truth, but now in like hindsight we realize that maybe that was like wrong, right? So to take like an extreme example, right? Like let's say like 500 years ago, like slavery was maybe like seen as like a normal thing, and now like we realize that like, okay, like I don't think anybody's like trying to defend that, right?
Right.
But like, at the time it was just like a normal part of life, and like, nobody was questioning it. And I think that like in order to so like once you find out that like one thing that you found was maybe untrue, then like you start to think like, well, what else is also not true? Because like your bandwidth is limited, right? Like if you are working a 9 to 5, if you're busy, you have obligations, you have kids, you have to like worry about your bills, you have all these things, and like people don't have time to like actually go and like vet to see like if things are like actually true, right? And if somebody makes like some sort of like YouTube video, or like makes some sort of like a video saying like, hey, like I think that like the government is full of lizard people, like, right, like I mean, you might start to believe it, right?
I think also way down in our brains, it's more important for us to belong than for us to be honest, right? And because survival is depending on belonging to your clan or tribe or whatever, and it's not dependent on you telling the truth often, right? So if your tribe says, we're going to kick you out if you don't believe this, you have this tendency to want to believe it because you want to belong. right? And that's independent of, kind of as a science tech person, I kind of like I'm a fact-based person, but facts are oftentimes uncomfortable, right? And it might lose you friends, it might lose you family, it might lose you all kinds of things to be talking about facts where you go, it's not that important to me to take a stand, this political stand, if I don't get to talk with my aunt anymore, or my uncle, or my grandfather, or my son, or my daughter, or whatever. I would rather talk to my son or daughter and believe these uncomfortable things and participate in their lives than not. And so that's a thing that again, one of those things that as more as if we want to prove that we're more than just animals, we have to fight against that tendency to be tribal over more important goals for our for ourselves, for humanity, and for the planet.
Yeah. And I think that hopefully AI will be able to help with that, because life is short, and while it would be nice to go and be logical about everything, like sometimes it's just hard, and we need to take like mental shortcuts.
Well, find ways. I mean, like people out there, find ways for AI to help with this. And I had this idea of a social media where a priori you tell people that half of the participants in this social media are avatars, agents of some sort of bots, but they're designed to be affirming. They're designed to be not hostile. They're designed to be interested in you, right? And a lot of people won't care, and if there's a bully or if there's a troll, the AI is designed to engage with them and slowly wean them out of the conversation and try to get them to be better citizens. And the beauty of AI is like trolls always like to have the last word, but AI can always have the last word. It never gets tired. It never breaks character. It never gets mad. It never gets fatigued. And it can be, and I'm not saying it has to be, take a big stick and whack them with it. It can be very non-judgmental and really engage with the person to find out why they believe what they believe in and how they can maybe believe something different that will make them more productive in the community that they're engaging with. And that would be kind of like a social media thing where, friends and people can get together, and some of the agents will moderate and maybe provide a little bit of lightweight therapy and actually pull out destructive people rather than just banning them, right? Pull out destructive people and try to coach them and to engage in more productive ways.
That's a really interesting idea for a social media. I also think that it'd be interesting if you didn't know who was bots and who you're interacting with.
Yeah, so I thought of that question. I've turned it over, and a lot of people have said that, well, if they didn't know who was bots, but I think trust is tantamount in this, and you would have to tell them a priori, because if someone feels betrayed, you will never ever get them back. No, right? But they'll be enemies forever. So I guess I like to not betray their trust.
What I'm saying is like, imagine it was kind of like a game where you said like when you signed up and like was super clear, it's like maybe like a big banner at the top of the page, like 50% of the interactions will be bots. And then like you don't know who it is, so like it's kind of like a game to try to like guess, like it's sort of like a
they're doing test. So they're doing that. There's a and I really don't like this show. It's called the Circle. And
I saw that.
They put people in a building, and it used to be that there would be a couple people catfishing. They wouldn't be who they said they were, and they would try to get people to believe in. They would, I guess, both people offer something in a traditional style. And this season or a recent season, one of the catfishers was an AI. Right, and it would be fooling. They told them that it was an AI, and it would be trying to fool people into believing it was a real person or a real persona of something.
Wait, so they said that like because
nobody knows who it is.
Right? Oh, so they said like one person's an AI. Else, like so what would it be like 10? How does the show?
It's like I don't know, 15 or 20 people, and everybody knows that there are a couple of catfishes.
Oh, okay,
in there, and they know that they're there lurking. They're just trying to figure out who.
So are you just like talking to like a wall?
Oh, so you're texting each other.
Oh, you're texting each other.
You're texting each other, right? And there are pictures, and some of them are not real. Right, so there are pictures of everybody, and the reason I don't really like it is because, well, for one, it encourages people to be dishonest about things, and it makes that into entertainment, and for two, entertainment is the worst of humanity, right? It's like to promote people being the worst of humanity as entertainment feels kind of gladiatorial to me. It's kind of like, oh, let's just, I don't know. It just rubs me the wrong way ethically.
Yeah, when you said entertainment is the worst, I don't know if I agree with that, but I do think reality TV, which brings out the worst in people and records them 24/7, forces them to be in uncomfortable situations and make mistakes as human beings naturally do, and showcase that on TV for the rest of the world to see.
To succeed in this program, you have to be dishonest.
Yeah.
Right, deliberately. And you know, to some degree, I kind of like feel worse about the people who watch it, right? Because the people who are in it know it, and they know what they're doing. It's like kind of a boxer, right? The boxer knows he could get beat up and whatnot, but the people deriving joy from watching somebody get beat to a pulp, I don't know.
But the interesting part where they sent an AI to pretend to be a human being,
right?
It seemed very successful. So
yeah, I don't watch the show, so
I watched a couple episodes of that season.
Yeah.
Because I was like, oh, this is
it's like a Turing
fun
test.
Yeah, it is a Turing test. Yeah. And the AI was able to construct this persona, and I think it was some kind of an agent running in the background that had some system prompt that said, okay, be a likable contestant in a game show, manipulate, lie, do whatever you can to get people on your side and have them vote other people off. And, you know, you got to be in the game, make alliances, be non-threatening, throw shade on other people. Yeah. So that was their loss function. Like, don't get disqualified. Whatever. They did a really good job.
Oh, no doubt. Because I don't think it's hard to do. I don't think it's hard to trick people, because people are inherently want to believe, right, the things that people say.
I guess, to be fair, in that reality show setting, everyone was primed to be a little suspicious of everyone else already. Sure. And statistically, there's like 10 people, one AI. It's going to be hard for you to
I think I just don't I'm a little squeamish about normalizing that as acceptable behavior, right? You see something at a show, and yeah, it's just Hollywood. Yeah, it's just a show. Yeah, everybody knows. But it normalizes the behavior so that if you see it in real life, you don't think twice about it. Oh, yeah, I was on that show. It was funny. I liked the show. I enjoyed the show quite a bit. Yeah, it was bad for this person to do that, but I'm used to it.
Agreed. This is going off topic a little bit, but I do think to maybe salvage some good out of this reality TV world, people do realize that they have to live their lives outside of this television show and carry on that reputation that they build in the show. So I think some of the recent contestants are realizing that, okay, they can't be absolute psychopaths. They need to be a decent human being, treat other people well, because it seems like they're all on average working class people who would really benefit from winning the prize and helping their family, their kids.
But holding that up as a prize, for this period of time, you have to be a horrible person, and we'll give you this prize that'll make your life better.
That's a choice. It's a choice. You have the option.
Sure.
Yeah, I guess. But in a certain sense, like, people don't necessarily have the choice. Because, like, I mean, if you have no money and you have a bunch of, like, debt collectors calling, and somebody says, like, oh, if you're a horrible person, we'll give you $100,000.
It's a better choice than, going out and trying to rob a bank or a liquor store, to be sure. But
yeah,
society should find better ways to provide for its less fortunate.
So I had something I wanted to ask you with one of your previous points. You mentioned we have obligations as human beings to the rest of humanity, to society, to
one of them,
nature. And I would say maybe those are lower down the list of your most absolute critical priorities. Closer to home maybe is, your immediate family, your partner, your kids, and so on. So remind me again, I think you have a son who's in middle school.
Yeah, and he's in high school.
High school now, okay. What advice are you giving him to be a capable member of society in this rapidly changing world, to maybe use these new technologies? And what is he gonna study? What are you encouraging him to learn? What tips or things are you trying to get him to?
It's first of all, let me talk about the obligation hierarchy that I sort of threw out. It's not static. Sometimes some of those obligations outweigh others at different points in time, and oftentimes they're conflicting with each other. In order to help my family, I have to do this negative thing for the environment, right? or something like that. So there's that. And then as far as the advice, he's his own person. The advice is the same as you would give kids throughout millennia, right? Don't lie, be a good person, be compassionate, look out for the less fortunate.
Maybe more specifically, since you're someone who's worked in Silicon Valley in tech, if he's interested in thinking about his career and going to college soon.
Tech is a good career. Tech is actually one of the few careers that going to college makes more sense these days. Colleges have gotten a little bit ridiculous in terms of the value proposition for students going into them, and tech is one that is showing to be actually worth the education. It's less expensive than some others, and you don't have to go to a Stanford, MIT to learn how to be a really good coder or some other kind of tech thing, and there'll probably be a job waiting for you that'll cover your college expenses, so your debt. And so
you still think so? When by the time he graduates, maybe 5 years or something from now?
I think the university and banking system has let students down, and so I'm going to encourage him not to go to a hyper expensive top tier school, because I don't think it's a value proposition. I think $500,000 in debt, even if you do get a dream job, you're going to be an indentured servant, a voluntary indentured servant for the rest of your life, and that's not a value proposition.
Well, the public schools here in California are not too bad, right? The UC system is relatively affordable.
They're all good. No, I like the UC system, especially if you're a resident. It's really, really excellent if you can get in. The price is good for residents. The problem is that there's a million international students that pay.
I'm one of them.
Completely willing to pay exorbitant tuitions because they have the access to the money. And there are more of them than there are people that are residents. And the colleges love them because they pay 3 or 4 times the tuition that an in-state person does. So there's a lot of pressure on state colleges and universities to increase the ratio of non-resident students, or decrease the ratio of resident students and increase the rate of non-resident students, because they can pay for all the really expensive gyms and food. Like I went on a college tour recently, and I can tell you the food was 1,000 times better than when I went to college. When I went to college, it was like a high school cafeteria. You walked in and there were like maybe 3 different entrees you'd picked, and you got your tray out and they put it on it. They had like 15 different stations with different kinds of ethnic food or seafood or and there was a grill, and there were literally 15 different stations they could get food at, and I'm like, they got to pay for that somehow, right? And that's, I think, the increase in tuition is covering that cost because it makes them competitive, right? And so, students, what's really funny is when you want a loan from a bank, usually as an adult, you have to have some kind of collateral. You have to prove that somehow you're worth it. And in the past, banks that would lend money to students, I think, did so because they were banking on the future career the student would have as being the collateral for the thing. So there's no real collateral. There's no real understanding. There's no like a car or real estate or anything like that behind it. So it's a future thing. And because of that, they could make it anything they wanted, right? They could make it, we think you're going to get a job that's going to pay a lot of money. So the banks would give bigger and bigger loans, and the universities were only too happy to, and I'm not saying this is a conspiracy theory. I'm saying this is just the free market in action, right? Banks would give bigger and bigger loans. Colleges would charge what the students are willing to borrow, and they just keep going up and up and up and up and up and up and up. And
it seems analogous to the health insurance industry.
In a way, there's a lack of transparency of transmission of the real cost to the consumer to make an informed decision. But banks can't make an informed decision because they don't know what kind of job the student's going to have. So if they get no job, then they're totally out of luck, right? If you spend $250,000 on a college tuition for a degree in economics, and there isn't a job waiting for you, well, now you've got this loan that's bigger than most people's house loans that you have to pay off through your entire life, right? People spend 30 years paying off their mortgage, right? When I got out of college, within 2 years, I had paid off my student loan. The student loan was literally 1/5 of my starting salary. And now the student loan is 2 to 3x your starting salary.
Yeah, I think that's true with the increasing student loans with the banks, but I also think it has to do with the government giving loans as well, because there's like both, like I think the federal backed loans, and then there's also like the private loans. So I think like there's a lot of money from there as well.
Well, the banks like to give loans because a lot of them are backed by the government.
Right. Yeah.
So that it's like the savings and loan scandals of the past, right? If they're guaranteed by the governments, then banks are only too happy to let you take as much risk as possible because it's not their dime.
Yeah, especially like if Uncle Sam was gonna back it.
There are some things there. Totally. I mean, I'm not saying that the government is good at that, or that's the government student loan programs are all really good, but they do actually have a cap, right? They don't go up to $400,000. They're the government, the amount you can borrow from the government is relatively small.
I think some of the doctors and lawyers loans do get up there.
Sure. But are they government-backed loans? Are they government loans? Are they?
I don't know.
That's a good question.
I think government loans have a cap. I don't know. I could be totally wrong. Your listeners can.
I was talking to someone from one of these loans refinancing companies, SoFi or Earnest or something else, and they mentioned the most expensive clientele or doctors,
Sure.
lawyers, who are still repaying their loans in their late 30s.
In their late 30s, and probably for I called it. I mean, the credit card companies did this too. I called it voluntary indentured servitude, right? You're choosing to get the credit card. You're choosing to run it up to its maximum amount. It's not something that someone is making you do. You're choosing to go to the school. You're choosing to take these loans out, right? And so the institutions can hide behind the fact that it's a choice that an individual is making.
It's tough to call it a choice when there is not a good alternative.
You
need to build a credit score. You need to get a big name college to get a good job.
So it's stacked, right? So that I was going there, and it is, you're choosing that's what they hide behind. But some of the, when they give you a credit card and they tell a college student, well, here's the minimum amount you can pay off. But they don't tell you that if you pay off the minimum amount, you'll never repay the loan. You'll never repay the credit. You'll never pay it off, right? So regulation needs to set that minimum amount so that you actually do pay it off in some period of time, or at least the person is made clearly aware of how long it takes them to pay off. Like if you buy something with a credit card, like a television, a $2,000 television, and you just pay off the minimum amount every month, you'll end up paying $10,000 for that television set if you ever pay it off at all, right? And even if you do pay it off in fairly big chunks, you might end up paying $3,000 for that television set that normally costs $2,000. And if you're the kind of person that can't resist just buying whatever you want, right? Because marketing is at your face, buy this big TV, buy this computer, buy this car, buy this blah, 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 and buy all this stuff, then you will rack up $20,000 to $30,000 in credit card debt, and you'll never pay it off. You'll never be able to get off from under it. And that's partly, I think, our system's problem, not just the individual lack of willpower.
Yeah, that's true. Because I mean, it's really hard to fight against that. I mean, like you have some of the smartest people in the world, just like doing everything they possibly can to just like sell a product to you.
Yes, to sell a product to you, and they will play on those cognitive biases that you have to have what your neighbor had, to fit in with the Joneses, to buy the big TV or the computer. They'll play on those.
Yeah, it's a losing battle. It's so hard. I mean, like I think that's actually a really interesting regulation proposal to raise the minimum credit card payment. To say like, hey, like maybe like the credit card payment is like $20. Like, oh, I can handle $20. It's like, yeah, $20 a month for the next 700 years.
Right.
Right.
I think they did change the regulations such that the recommended minimum payment had to pay it off, right? Because for a while there, the recommended minimum payment would last in perpetuity. Right?
Yeah. I mean, that is just
I think that's kind of predatory.
Actually. That's terrible. Yeah.
But I mean, caveat emptor, right? Let the buyer beware. It's a person's choice. Just because they didn't read the fine print, they're still liable for the decision they made.
I mean, for sure, yeah. But sometimes, like the fine print is, really hard. Like you need to have a law degree to interpret it. Sometimes.
Also, when is the last time any of you guys read a fine print?
I mean, you probably asked the wrong guy.
I plead the fifth.
But actually, one thing that I've been, to bring the conversation back to AI a little bit.
Yes.
Yeah. So one thing that I've been doing a lot is whenever I click agree on the terms and conditions, I'll throw in the terms and conditions to ChatGPT.
Oh, and to summarize it?
Yeah, and be like, hey, like, what do you like? Anything I should be aware of? And typically it's like the standard legalese, but sometimes you can find some good stuff. But yeah, I would recommend doing that. Just so you kind of know what you're agreeing to.
So I think beyond, like, I want to make people better at doing that themselves, right? I want to train them to recognize when these things are happening. I think AI can be really useful as a tutor or a counselor or advice or whatever on decisions people might make or understanding problems so that they learned not to make those mistakes again. Now, I have a lot of faith in humanity, and maybe that's a little misplaced, but I really think AI can be used as an equalizer that way.
Yeah, I think so too. I have like massive optimism for the future. I think that for sure, there's a lot of problems, and it's important to recognize those problems so like we can fix it. But I think that the problems were created by humans, and then I think like humans, maybe along with the help of AI, like we can solve those problems too. So like I don't know. I think that like the future has the opportunity to be extremely bright. Because the thing is like we collectively, as humans, we build the future, right? So like we can make the future that we want.
I would argue that and this is an argument I made 30 years ago, is that our ability to make ethical decisions around technology doesn't keep pace with the leverage that technology gives us to make bad decisions. And I just finished this book called The Alignment Problem. And one of the last things he says in the book is luckily we're really incompetent. Right? Because the technology we've created, if we had employed it perfectly, would probably have destroyed us. But the fact that we make mistakes and we bumble on things and whatnot has prevented it from actually doing more damage than it could actually do.
So maybe trying to end the conversation on a brighter note, what are you most optimistic about? What is the best case scenario that you're looking forward to?
I think there's a ton of people out there that feel as I do, that are like Mark, are optimistic about and who are trying to drive humanity to better positions. And I think AI can do that. But it's a tool like any other tool. Can be abused, can be, it's just a tool. It's in people's hearts and minds. But I think there needs to be, unfortunately, the incentives to use it, not for evil per se, but for personal gain, which causes certain bad things to happen. Just because everybody looking out for themselves doesn't mean that anybody's looking out for, say, nature or anything like that, right? Those things are really hard to change, but AI can kind of maybe level the playing field somehow. Can play on our like, imagine you could have AI play on our cognitive biases in a way that gets us to do good, rather than in a way that enrages us or makes us afraid, right? And I'm not saying trick people into doing good using their cognitive biases, but recognizes when things like the desire to be with a tribe is you're doing it because you want to be with your family, and you don't change who you are based on that. You can still recognize, hey, I've got facts, I've got information on my side that says that this, and maybe you'll be able to fight the good fight and nudge them to a more honest position, and one that looks at humanity in general and some of those other obligations other than the ones to yourself.
So, Shashank, I know you're trying to like semi-wrap this up, but I want to ask one more kind of follow-on question, which hopefully won't turn into too much of a rabbit hole. But
stop me then.
So, you kind of mentioned how like AI may be able to help society and whatnot, and I'm curious, do you think there's ever going to be AI in government? Do you think that there could be maybe in the future? I don't know exactly how we would be able to do this with the current political process.
It's going to be in weapons systems.
Yeah. So, but like when I say like in government, I mean like a leadership in government. Like, do you think we could ever have like an AI president?
Maybe starting small, an AI governor of California.
I think an AI avatar has the potential, maybe not as a governor or president, but as a voting member, let's say, with a certain amount of power. Like, say, humans 51%, AI 49%, right? So humans have veto power ultimately, but as an agent that can. So the thing about AI is it doesn't get offended, right? It doesn't have the emotional things that happen in a lot of government positions. It can look at the information and the data. It can look at what's been effective and what's not been effective, and it can recommend things that it thinks are going to be more effective or less effective. And it does. There's no BS, right? It'll just if it's programmed to, solve a problem, say homelessness or world hunger or something like that.
Or it could actually probably balance all of the problems at once.
It could certainly balance all the problems at once. Yeah. It can handle more data simultaneously. Right. That's what you're getting at, than a human could.
Exactly.
And it wouldn't have the same. It would have prejudices based on the data it was trained with, but if there's enough people understanding some of the prejudices, I think some of the prejudices we have are very, very sort of isolated and personal to a particular politician or a particular thing. You can, just like radiologists, you can average out all those things to an ideal of what we want a governor to be, or a legislator to be, or a law to be, and it can tell you what that ideal is, crunch all the data, tell you how successful it can be within that system, with real information that people can follow or not follow. And then there won't be any BS. There won't be any spin. There won't be any of this, is capitalism inherently evil or is it inherently good? Yes, there should be millionaires. Those that shouldn't be. But you can say, well, I want everybody to have a minimal lifestyle. How do we achieve that? And maybe it'll say no billionaires, right? And that'd be the solution. Maybe it'll say, like, here's one that I think would be really radical: is no taxes throughout all your life, except at the very end, 100% inheritance tax. Right? So everything goes back to the government. And so that way, there's all this complaint about people on welfare and food stamps and SNAP and all those programs taking advantage of the program and not working and being lazy. Well, the offspring of wealthy people don't have to do any of that stuff. They actually can not do anything, right? So how do you incentivize them to participate in the society with everybody? How do you prove to wealthy people, well, look, let's globalize the playing field, not just the unfortunate people, but everybody. And so in your life, you can't count on any of your parents' inheritance. You have to make your own way in your life, right? And then nobody's taxed, right? So all the money you earn, you keep. You want to be a billionaire, if you can get there, you get there. But at the end of your lifespan, none of it goes to your children. It all goes into helping society become better.
I think maybe Marcus might be thinking about something that I'm also thinking about. That only works until we start living forever.
Yeah, exactly.
Well, yeah, that's a long way out, and I think that's a long way out. I think that's a longer way out than other problems we have. I think it's coming. There's some great science on this. There's a number of problems that if we solve, I think it's like 10 or 11 problems that we solve with human biology, and you can make longevity be in the many 100-year range.
Or augmented human-computer interfaces.
Sure. I think
then maybe we get into the definition of what it means to be a person if you're living on a chip. Well, maybe a Cerebras chip.
Yeah, and this is where technology will stratify society, right? Like if I'm augmented, if I can afford to be augmented with a super brain, right, that gives me access to information about everybody everywhere and calculations I can do in my head and all this information, I'm going to be a better employee than most people, only because I have this super brain. And so I might be able to do the job of 10 people. I might displace those 10 people, right? And so there's that technology danger too. Again, technology it's really like the end of this book that I was reading on the Lander problem talked about technology as being this stallion galloping across the field, and our ability to ethically handle that technology as being this weak-limbed foal just trying to find its footing, right? And it's kind of true that 1,000 years ago, we didn't have the technology to destroy the world accidentally. No one person could probably do it. Now, one person or a handful of people can do an enormous amount of damage, including possibly eliminating humanity as a whole, right? By making mistakes, by using the leverage of technology. And one could argue it might be happening in tiny chunks by the technologies being used, for instance, for finance, for politics, for fake news, and creating all these things that are really believable. Those tiny chunks are bites out of humanity's probability of surviving, right? And people need to be out there, and that's what I would encourage people to, looking out for how to counteract that sometimes not even conscious erosion that happens just by people trying to make the best for themselves.